Hello guys, so today we are here to solve this shortest bridge problem. This is today's daily lead code challenge problem and we are going to solve this problem. So let's start. So to solve this problem, what we are going to do, we are going to start one, loop, and we'll be, going through the grid which is given to us. And in this grid, there are exactly two islands and we'll be, uh, finding, or we'll be looking for the shortest possible bridge in between those two islands. So to find the islands, what we are going to do, that will be, we'll be traversing this grid, and wherever we first come across a 1. So if grid of ij is equal to 1, if grid of ij is equal to 1, then we will be, um, we'll be, marking all those, points with the explore DFS. So we'll be marking all those, grid I and row. Okay. 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 So what we need to do, we need to have one, we need to have one cell of, uh, so we need to have one cell of, one deck of, uh, integer array, which will be having all the rows and columns. And as soon as we are done with this, we'll be, as soon as we are done with the first, uh, after the first call, we'll be, coming out of this loop. So let's do break. And we'll be having one outer label here. Okay. And after this, we'll be, doing one shortest path BFS. Okay. And we'll be passing this grid and this deck. Okay, so first of all, we have to write this explore DFS. So this is not going to return anything. So we will be, writing it like this. And in this, we'll be passing this int array, grid, int row, int column, and then deck of int array deck. Okay. So first thing for doing DFS is that we'll be checking if row is less than equal to if row is less than 0 or row is greater than equal to grid dot length, or call is less than 0 or call is greater than equal to grid dot length, or grid of um, row call is equal to 0, then we are going to return out of this grid. Otherwise, we'll be marking this row and call value with, let's say, 2. So we are marking all the, first island's grid value as 2. And then in the deck, we are adding add last. At last, we'll be, doing this new int array row call like this, and then we'll just be exploring this DFS. So to explore this DFS, what we are going to do, grid row plus one call deck. So like this, we are going to do this DFS traversal. And now after doing this DFS traversal, we need to, return the, shortest path. So for shortest path, we are going to do BFS. Why BFS? Because BFS takes care of that minimum aspect. Okay. DFS will go in one direction as deep as possible, but we don't want to do that. We want to have the shortest path from the first island to the second island. And that's why for all the, cells of this, for all the cells of this grid, we'll be doing this. Um, for all the cells of the first island, we'll be doing this, traversal, this shortest path traversal. And how are we going to do it? So it is simple. So first of all, we'll be, doing this, and then what we'll be doing, we will be, taking this private and shortest path BFS int double array grid deck int array deck. Now, so what we want to do, that we want to have, this. So first of all, we have to declare one level variable. So this is what we are going to return, and then we'll be entering this, deck dot is empty. So we'll be putting this, not empty. Why? Because this is the standard BFS implementation. While deck is not empty. And then what we'll be doing, that we'll be taking row is equal to, and array ARR is equal to deck dot remove first. Okay, so we are getting this row is equal to ARR of 0 and call is equal to ARR of 1. Okay, and then int size is equal to deck dot size. Okay, okay, and then we'll be taking for int I is equal to 0, I less than size plus plus I. Okay, and we will be, no, so this part we should do inside this. Okay, so this part we are going to do inside this, and array ARR is equal to deck dot remove first. So here we are extracting the first element from the deck, and the row value will be ARR of 0 and call is equal to ARR of 1. Okay, and then we can put a check if row minus 1 row, because we need to do the, things, this traversal in four directions, and grid of row minus 1 call is not equal to 2. If it is 2, it means it is from the first cell itself. So in this case, what we'll be doing, if grid of row minus 1 call is equal to 0, then we are going to return the level. Otherwise, what we are going to do, grid of row minus 1 grid of row minus, okay, grid of row minus 1 and call is equal to 2. And then after doing this, we'll be doing add dot last of new int array row minus 1 call like this. And then I think we need to just do a copy of this 4 times, because we will be doing the traversal in 4 directions, and we need to put the checks accordingly. Row plus 1 is less than grid dot length. Here we have to make it row plus 1 instead of row minus 1. Okay, and then this will be row plus 1, and then this will be row plus 1, and then this will also be row plus 1. So row plus 1 is less than grid dot length. That's fine then. Now we have to have one condition where call minus 1, because this island can be 4 directionally connected. So instead of row, we have to make it as call, and this will be as it is. Here it will be call minus 1, and then row call minus 1, and then row, and then call minus 1. So check row call minus 1 is not equal to, yeah. Oh yeah. So not equal to 2. It should be, if it is equal to 1, then we have to make it as, 1 is the second island. Okay. Okay. So this grid in all 4 directions, if it is 0, then we are, uh, making it 2. If it is 1, we are returning that, value. So now it will be call plus 1. Call plus 1 should be less than grid of row dot length, and then this will be call plus 1, and then this will also be call plus 1, and then this will also be call plus 1, and then this will also be call plus 1. Okay, so these are the 4 directions: row minus 1 less than 0, row plus 1, grid less than grid dot length. All these things we have checked it correctly. 1 is equal to 1 plus 1, row call minus 1 is equal to 1, call plus 1, call plus 1 equal to, yeah, like that, correct. Okay, okay. So yeah, this is fine. And now we will remove this, and then this is this. And so after, traversing in one direction, we'll be, incrementing this plus plus level. Okay. And at the end of this, here we'll be returning this, return the level, and here yeah, so let's run it. So this is the way I have solved this problem. Grid I go deck, where grid IJ. Okay, so here this index is out of bounds, exception. Oh yeah, it should be greater than equal to 0, like that. Call minus 1 also should be greater than equal to 0, not less than 0. Okay. Yeah. Stack overflow error. How come row is less than zero? Row is unequal to call. Yes, it should be the row dot length, not. And if this is equal to zero, yeah, perfect. Time limit exceeded. So what is the problem in this? Mm, mm, mm. Row is less than zero, row is greater than equal to grid dot length call is less than zero to grid equal to then to uh, oh yes, 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 I now make it. Or grid of row, we have to exclude this. So suppose in the first step we are marking some cell as true, then also we have to, make a return. Okay, perfect. Now we submit it. Yes, so this is the way we can solve this problem. Yeah. Mm. We can put one condition here to make it, even faster. We want to find only the first cell. So we can, put one condition if grid of, then this can be an issue. It's okay. So this, yeah. So this way we can solve this problem. Any other efficiency that we can add in this problem. But anyway, this is a very interesting problem. Let me know if you have any doubts. I'll definitely try to, answer those doubts. Put your doubts in the comment and I'll answer those doubts. Thanks a lot.